All right, so see if you can get the rest of them. Is that enough? The good news is we've already done all of this work. All right, so go ahead. I'm going to work out these other 3 problems and just find the trig form. But maybe you could give it a try. Graph them. That's going to be really helpful. I always graph them. And then see if you can come up with, all you got to do is find the distance from the origin or the hypotenuse, which we called r before, square root of x squared plus y squared, and the angle that points to it. Okay, so let's try the next one. If I wanted to draw that picture, 6 root 3, and by the way, there's a reason I'm giving you 6 root 3 and 6. That should be a special triangle. We're going to be working with a lot of special triangles here. Let's clean this up a little bit. Okay, and I can mark that answer down just so we know what that second one was since we already did it. So let's see, that was the same thing as the square root of 2 times the cosine, right, the x value of 3 pi over 4, plus I times the sine of 3 pi over 4. Okay, how about this? 6 root 3, that would be, root 3, 1.7. It's probably going to be off my graph here a little bit, so that's okay though. Minus 6 would be here. I'm just drawing a triangle. It's all right triangle trig. It's all trig we've done before. If I want the trig version of this, I just need to figure out this angle and this distance. I'll call it mod z. Okay, and we've done all that before. If this is 6 root 3 and this is negative 6, then this has to be a 30-degree angle, or pi over 6, making my reference angle 11 pi over 6. Okay, recognize your 30, 60, 90 triangle. This is 6 root 3, and this would have to be 12. You wouldn't even have to do the math. If you recognize that, it should be double the side of the smallest side. Or you can do the math. Mod z is the square root of this side plus this side, each of those squared. And that should be 12, but you can check my math if you want. Okay, and that's it. So 6 root 3 minus 6i is equivalent, let's come down here for that one, to 12. And then just remember the form. It's the cosine of the angle. And we can use degrees or radians, but we've really shifted to radians, so we like radians. And then just repeat the angle. And if you ever want to check your math, just take the cosine 11 pi over 6, the sine 11 pi over 6, multiply it by 12, and you should get that. Okay? All right. How about part C? 5i. This one's going to be a little bit easier. Okay, so 5i, graphing it always helps. So to get to 5i, I'm just going to graph that on the imaginary plane. And that's going to be right up here. 1, 2, 3, 4, 5. Right here. Same thing. What's the distance from here to here? Oh, that's easy. That's 5. And what's this angle? Oh, that's easy. That's pi over 2. Cosine of pi over 2 plus I sine pi over 2. What do you think about that? You've learned that 5i is equivalent to this thing. 5 times the cosine of pi over 2 plus I sine pi over 2. Easy to check. Cosine of pi over 2 is 0. So that would go away. Sine of pi over 2 is 1. 5 times I times 1 is 5i. Negative 10's right here. What's the angle that points to that? Oh, that's pi. And what's the distance from the origin? Is 10. So be careful here. That's positive 10 times the cosine of pi plus I sine pi. Okay, let's do these. So let's go the other way. I don't even need to draw anything. And this is why these are so important. Why I always emphasize this, that you know the cosine and the sine of these special angles. All right, so if I want to convert this, I just kind of do the math that's in front of me. So 10, what's the cosine of 5 pi over 3? What do you need to do to find that? I can do this in my head. Of course, I've been doing this forever, but you should be able to do this in your head as well. You say, okay, Cosine of pi over 3. There's a couple ways to do it. I always remember that the cosine of pi over 3, cosine of 60, is a half. Okay, so I can just say, I know it's a half, and then I decide if it's positive or negative. And I can do the same with the sine of 60. Oh, that's root 3 over 2. Okay, and then I say, well, wait a minute, that 5 pi over 3, that's in quadrant 4, so the cosine's positive, the sine's negative. And then I could run the 10 through, and that's equal to 5 plus, that's 5. And then if I run the 10 through here, I'd end up with 5 root 3 negative. So it would be negative 5I root 3. Okay, which, by the way, looks a lot like that, right? Which you get a lot of these because a lot of them are going to be special triangles. Okay. How about, does that make sense? How I got to 1/2 and root 3 over 2. You just got to know them. If you need to do a little more work, and you say, well, wait a minute, I don't remember 5 pi over 3. You could do, here's how we did these before. You say 5 pi over 3, that's right here. Reference angle pi over 3. Pi over 3. Right, that's a 30, 60, 90 triangle, and you go from there. However you get to this number and this number, that's up to you. There's a bunch of ways to do it. Okay, how about part B? It's 6 cosine of negative pi. Negative pi is the same thing as pi, so the cosine of that is negative 1. And the sine of that, of course, would be 0. So this is going to be negative 6 plus, and then the imaginary piece goes away. 0 times I is 0. So that's it. This whole mess right here is the same thing as negative 6. All right, so that's converting back and forth. So you have a bunch of those for homework. I give you the Cartesian form of a complex number. You give me the trig form. I give you the trig form of a complex number. You give me the Cartesian form of the xy form. All right. This is the same problem. I just gave you a graph for this one if you wanted to graph this to get a more accurate picture. Like here, if you needed to do a little more work for that first one, you could say 10, 5 pi over 3. You rotate it around, and you're over here. All right, you're pointing to this place in space. All right. I say I go distance 10, rotate 5 pi over 3, and that points to this place in space. There's another way to do that. Go x direction a certain distance, y direction a certain distance. And that's what we did here. We found that to be 5 plus 5I root 3. So that means in this triangle, this is distance 5. My scale is a bit off. This is distance 10. So if I did a better job, let's try and do a little better job of my scale. If I rotate it around, and this distance was 10, this is what I should have as 10. That looks about the... I should be better with the angle too. Let's try and be good here. Okay. That is a distance 10. That's about the same distance. And then if I do my triangle, this would be 5, and this would be 5 root 3. That's a little bit better. And this, of course, is the imaginary. The distance from here to here is 5 times root 3. If you want, you can put the I in there. It's kind of up to you, as long as you have it when you're done. And that would be another place. Again, we're trying to point to this point in space, two-dimensional space. I could tell you, okay, travel 5 this way, 5 root 3 this way, you're there. Or I could tell you go 10 out, and then rotate 5 pi over 3, and you'd be there. 10 out, rotate, and you'd be right there. Okay, let's see. Now we get to our 4 operations. That's the rest of this lesson, 4 operations. 3 of them are going to be real easy. I'm going to show you how easy. Multiplying, that's 1. 2 is dividing. 3 is raising to powers. Let's just abbreviate. Okay, these 3 are going to be real easy. And then the fourth one, we take roots, is going to be a little more complicated. All right, so in the next video, I think we can knock out these. I'm going to show you how easy it is to multiply, divide, and raise to power when it's not in rectangular Cartesian XY form, but when it's in trig form.